Hi, in this tutorial I'm going to show you how to develop a web application using Node.js and the Express.js web framework. We will then deploy our application to AWS using Elastic Beanstalk environment. We will develop a landing page where we collect and manage sales leads. You can freely use the resulting source code as a starting point to develop your product, and we will cover all of the concepts that you need to know to build a fully fledged web application using Node.js. We assume intermediate programming knowledge but no background in web application development or Node.js. Okay, let's get started. So a little bit of background on Node.js. Many years back, developer Ryan Doll explored the idea of using JavaScript for server-side programming with the main motivation that existing HTTP servers could not handle lots of simultaneous connections efficiently. Meanwhile, also Google's Chrome browser team developed a new JavaScript engine from scratch called V8, and the unique property of V8 is that it was built to be much faster in interpreting and running JavaScript compared to the other browsers. And Node.js took Google's optimized V8 JavaScript engine for server-side programming, also creating a setup that allowed for much more scalable handling of requests, and also a package manager for managing the open source JavaScript libraries was introduced called npm, and Node.js was born. Now, before we install Node.js, we're going to start by installing a script called nvm. So go ahead and type nvm in your browser and click on this link. NVM is short for Node Version Manager. It's a script to manage multiple active Node.js versions on a single computer. So let's go ahead and scroll down to copy and paste the install script for NVM, and we'll paste it on our terminal. Now, I already had NVM installed, so this step may take a little longer in your case. And what you need to do is close and reopen your terminal so that the NVM script can initialize while your terminal starts. You can check that your installation was successful by typing nvm -- version. We're now ready to install Node.js, so let's go back to nodejs.org. We're interested in the long-term support version of Node.js, and as of this video, it is 10.15.0 is the version that we need. So we go back to our terminal and type nvm install 10.15.0. This step may take you a little bit longer. You should have now Node.js installed and being actively used. Just for the sake of showing you how it works, you can also install other Node.js versions. Let's go for 8.11.3, for example. And you can switch between Node.js versions by typing nvm use. So let's switch back to using Node.js 10.15.0. Now, for our application, we're going to use Express.js. So let's go ahead and visit express.js.com. Express.js is a web framework, and the power of it is in its simplicity. You can develop very complex web applications, yet it is a minimalist web framework that is very easy to grasp. And this is the install command for Express.js, but we're going to use another tool called the Express generator that will give us a good starting point and a directory structure. So let's go ahead and copy and paste this command in our directory to install Express generator. Now here in this command, npm, as I mentioned, is the Node package manager. We will use this to install packages, and here the -g stands for a global install, which means the installation is going to happen the computer-wide and not just one particular project. So I'm going to press enter now. And now we can go ahead and run Express generator to generate our application and a useful directory structure. So I'm going to copy paste this command. Here --view equals pug means we're going to use pug as our HTML templating engine. So I'm just going to press enter, and we have now created a directory structure for our application. Now that we have generated a skeleton directory structure for our application, I want to go over each folder we created. So let's go ahead and start our text editor. And let's take a look. So under my app, the public folder contains our assets. Assets are static files that your HTML files makes references to. Each HTML file will refer to certain images, such as logos, and some JavaScript files that need to be run on that web page, or style sheets that describe the style on a web page. The routes folder contains the router logic. We will get to routers in a little bit, and it's one of the key parts of our application. And finally, views contain the representation of each individual HTML page in our application. Notice that these are named pug files. Each of them get converted to separate HTML page. The bin.ww file contains the initialization script for our web server. And one of the notable files is app.js. This is the main entry point for our entire web application. And also we have the package.json file, which is a recipe that contains the list of open source packages we need to install to run our application. Now let's go ahead and install these packages and run our application as it is. So we go back to our terminal, cd my app, and we type npm install. We're pulling and installing all those packages. This file contains not just the packages that we need, but also npm allows us to fetch all the dependencies that these packages have. And now in order to run our application, we need to type this command. And once I press enter, the web server is running on port 3000. And when I visit localhost 3000 on my browser, I get to see this web page served. If we go back to our source code, app.js is the most important file that we care about. App.js defines our web application, and Node.js, Express.js applications are monolithic, meaning that every piece gets put together into a single application. And let's see how that works. We first import modules using the require statements, and typically these modules are those ones that we find under the package.json file. These modules here, you will see that they have been imported and assigned to variable instances. The one we're interested in is this express variable. As you see, the require statements includes the express package, assigns it to a variable, and then later on we call the constructor for express and assign the result to a variable called app. An app is an instance of an express application. Typically this is a vanilla instance, and then we make certain method calls to modify and configure our application, and also use and include other modules. Here we first set that the views are included in a directory called views. This is what this line does, and we have, as you can see, a views directory here. And next we set that we are going to use pug as our view engine. So the app instance that is unmodified and new gets modified by these set calls, and then we have certain use method calls where we define further configuration and further components that we're going to use. And one of the notable ones is the index router object that we have defined in this project. If you go up here, we use the require statements to include an index.js under the routes directory. Whatever that has been exported from this index.js file is assigned to an index router variable, and this instance is then used for the path that is slash. So this line means that our application is going to use an index router for the slash route. And that's how we also connect pieces of our application into one monolithic instance, because index router was defined here under index.js, and it has been included from app.js. Let's take a look at how the routes object is defined. If we go under routes and index.js, again, we are requiring the express package. We have a variable called express, and then we call a router to create an instance of an express router. And just as we did here, the router instance here is a vanilla instance. It hasn't been modified. And then we make some certain method calls to define it further. In this particular case, we're defining a get method and how to handle this slash path with a function. And then we export the router instance that we have created to be included by another module. And app.js includes that router here. And that's how we connect it. And The router object, to recap, is a vanilla instance. Then we make some modifications on it, and then we export it. And this pattern is used throughout the application. This is how you divide your application into separate instances. Now let's take a look at what a route handler is and how it works. Here we have a router variable that is an instance of an Express router. And this router variable has several components that we care about. The first one is that we're making a call to a get, and this defines that the route handler is associated with the get HTTP method. And then the second component we're interested in is the path. So typically a router will match a particular path used in a URL. And then finally, there is a handler that gets called if a path is matched. To look at it more closely, if this is our URL, the first section defines the protocol being used, and the second one is the domain. And then finally, after the slash here, we have a path component. So a router object will look at this path and see if it is a match for the path that it has in its own definition. Finally, the router will call the handler that's associated with it. The last bit of detail here is that the get method here is defining the HTTP method that this route handler is limited to. It only responds to this get method. If there are no routes that match for a given path or HTTP method, our application generates a 404 error, which means not found. So as a recap, under routes index.js, we're creating an Express instance, and then we're calling express.router to create a router instance. And on this router, we're defining that for the HTTP get method, if we are looking for the path slash and it gets matched, we call this function as our handler for this route. And under app.js, we have index router representing our exports from routes/index file. And then we have this statement here, app.use, and for the slash path, we're using index router, effectively meaning that when we type this root path with no slash or slash, it means the same thing essentially. And when we press enter, we call the route handler that's defined here, which renders our index page. And that's how essentially our route handler works. Before we dive into source code and define routes and handlers, let's cover what an HTTP request is and how a request sequence works. The HTTP, short for Hypertext Transfer Protocol, defines multiple methods for browsers to communicate with web servers. And the HTTP methods allow the browser to take different actions. The get method simply fetches a resource from the web server, such as a web page. When we make an HTTP GET request, the server typically responds with a resource, such as a JSON object or an HTML file. And in our current scenario, we are interested in sending back an HTML web page, and we use the Express.js specific method called res.render. A res.render will generate an HTML page, and our web server will respond back to the browser request with a web page. And the other method we're interested in is called HTTP post. This is typically used for submitting data to a web server. When you fill out a form on a web page and you press the submit button, the data is sent to the web server, and typically an HTTP post method is used. There are multiple HTTP methods, and what method is to be used is defined in the form definition on that particular HTML page. But most of the time, and almost always, a post request is used. And once the server receives the post request, it does something with the sent data, such as updating a database. And then the server typically calls the res.redirect method. Again, this is specific to Express.js, to redirect the browser to another URL or path. So the server responds with a redirect after processing the data back to the browser, and finally the browser will do another HTTP GET request as a third step, fetching the route that it has been redirected to. Now, there are a few more HTTP methods, but this gives you the foundation for developing a rich web application. Now you know enough to develop routes, route handlers, and develop your application. One of the issues with our route handler is that the logic that matches a URL pattern is here, but also the handler function, the handler logic itself is defined as part of the route handler. And what we want to do is separate these two so that we have a modular approach. So we go to our terminal and I'm going to create a directory called controllers. Controllers essentially are a collection of route handlers. I'm going to copy this function from here and place it under controllers in a new file. Save it here and give it a name called index and save it with the name index.js. And if I go back to the routes and define index as an instance of what we have exported from our controllers index.js file, I can now refer to the handler that I've defined from this route file. So if I go back to controllers, as a recap, we have an index.js and we have a method called index that we're exporting as our handler, and under our routes, let's save this file again. And under our routes, we are importing it as a variable instance called index, and we're assigning the index handler for this route. Let's now save our application, restart it, and see if it will work. So I'm restarting the application and typing this URL, and it's working. So controllers allow us to separate handler logic, as you see in this example, from the route handler logic. And we're going to build many more of these controllers. Now let's take a closer look at what our controller function does. So if we go under controllers index.js, we named our function as index, and the only call it has is to a call called res.render. The res.render call renders an HTML page from a template. The first argument is the name of the template file, which is index. If you see under views directory, we have a file called index.pug. And the second argument is a JavaScript object with a key value pair. The key is title and the value is express. Now under app.js, we did define our view engine as pug, and we did define that the views are located under the views directory. So Express.js knows where to search as the starting point for view files. So when we pass index as the first argument, it will go and look at the views directory and find that there's an index.pug file here. And then pug will convert this template into a real HTML. If we look at this second parameter again, title colon express, we also pass this as a parameter to pug. So if you look at index.pug, it will use the variable and replace it with its value. There are two cases where the value is being used here. We'll get to this when we look at pug in more detail. But essentially our controller function simply renders an HTML page. It responds with a HTML page back to the requesting browser. Now is a good time to use version control and check in all the files that we have created. So I'm assuming that you've installed Git, and I'm going to initialize a Git repository here by typing git initdb. Now we've initialized the repository, and you can check that we have created a .git file in the current directory that stores all the files by our Git repository. And now I'm going to check in all the files, but before I do that, I need to create a file called gitignore under my app. Let's create that file and type node modules in it, because node modules are installed open source files. They're not part of our project. And gitignore file having node modules will exclude those files, all of these files from our version control. Typically, any file that gets auto-generated or external to your repository, you should exclude by using a gitignore file. Okay, going back to the terminal, I'm going to make my first commit by typing git add dot. Dot here representing the current directory. So I'm going to add all the files in my current directory to the git index and commit them by typing git commit -a, meaning commit everything that is in the index to git. So as you can see, we have a bunch of files being committed, and we're also including the gitignore file. So let's type initial commit and save and exit, and we have essentially committed our first change to our Git repository. To get the full source code for the tutorials, if you go to this website and scroll below, you will see posts with programming snippets as well as the link to the source code for those tutorials. And if you have questions, you can click on this button on the same page, become a member, it's free, and then you'll be able to add comments to tutorials and get answers. Now, one of the problems we have is that every time we make a modification in one of our source files, we need to restart our web server because the changes made to source files are not being recognized. And in order to remedy this problem, there's a tool called Nodemon that we're going to install. So I'm going to stop our web server and I'm going to install Nodemon by typing npm install Nodemon and then also typing save-dev. What this does is the save dev will save Nodemon as a developer dependency, meaning that we only need to install it when we are developing our application. So if we go under package.json, we now see that Nodemon is a developer dependency. And now we need to modify this line so that in the case of an environment where we're in production, we're still using the standard node command, but in case of development, we're going to run Nodemon instead that monitors for changes in source files and restarts our web server. So for the start scripts, I'm going to go ahead and type if the environment is production, then we use node.bin www, else we use nodemon bin www and then fi. Now this should work and we are going to use Nodemon to monitor our web server. So let's go ahead and try running this. Okay, as you can see, Nodemon has started, and when we make any source code changes, it's going to automatically restart our web server. Now is a good time to make a git commit because we've installed Nodemon. So I'm going to do git add package.json and then git commit -m install Nodemon. Now I'm going to cover the most common web application development pattern where we are going to build a landing page with various routes to collect sales leads, manage them, view them, delete them, and edit them. Let's go ahead and rename the variable index as landing because we're going to build a landing page. And our controller is going to be called landing, and we're going to name our first method that gets our landing page as getLanding. If we save this file and go to controllers index.js, let's rename this file as landing.js, and first function is going to be getLanding. And also let's rename the view. Now, when we fetch this file, we're going to display a form where if a visitor likes our service or our value proposition, they will enter their email address and send us that information in a form. So I go under views landing.pug, and right below this paragraph, I'm going to design a form. The form element takes one parameter called the action. When we submit the form, which path we're going to use is defined by action. So I put a comma, and for the second parameter, I'm going to use the method called post. When you submit a form, the method that has been defined in the form is the one that the browser will use for making the request. So we're interested in using the post method. And I'm going to define an input element of type email, and we're going to use a placeholder. Let's write here, enter your email address. Notice how there is an indentation here. Pug nests HTML elements by using indentation. So inside form, we have nested an input, and also typically we want to nest a button inside a form so that the button is associated with that form. So I'm going to define a button element of type submit. When this is a submit button, that indicates that we're going to submit the form that the button is nested in. We're going to use a name for the button called submit, and I'm going to now save this form. Let's make sure all of the files are saved, and if I now restart my application, I should see the form being served. If I press enter here, right, so we have this enter your email address form with an input and then a submit button. We're also going to commit our changes by typing git add. Because we renamed some files, we need to explicitly add, let's do git add views, git add controllers. Let's see if we have captured all the files. I do git commit -a to commit all the changes. Landing.pug has been registered as a new file, and so is controller landing.js, but we missed views landing.pug, so I'm going to explicitly add that file landing.pug. Okay, now if I commit, we should be covered with all the files that we have renamed and added in Git. So I'm going to write a commit message, landing page getting started, and first form. Typically in Git, you first summarize your change in a single line, and then you would leave an empty space and then include further information in the second paragraph. But at this point, we don't need to mention much. I'm just going to leave it at the first line. Now that we have defined this form, we're going to develop our first post route. So I go to routes index.js and include a new router with the post HTTP method, and then I'm going to use a new handler called landing.submit lead. Because we're looking for sales leads, it is called submit lead. I'm going to save this file, go to the controllers landing.js. I'm just going to copy and paste this first handler that we had, and I'm going to name the second one as submit lead. When we submit our form from landing.pug, there's this input element. We forgot to name it, so I'm going to define a name for it called lead email. When the form is submitted from that browser, we're going to be able to access the value inside this input element with the name lead email by going to our controller. Let's delete this statement here. We're going to print out the input element that we have received, lead email. And the way we do that is by using the body parser library. We are going to do rec.body lead email to print out the value. I believe I need to include the package called body parser in app.js for this to work, but it turns out Express.js already includes this functionality. This allows us to retrieve the values for input elements when there is a handler for a post request. If we simply do rec.body.lead email, we're going to be able to access the value inside the input element. Now, this handler is successfully reading this data, but we can't leave it at that. We need to conclude the request. So we're going to do a res.redirect, and we're going to use the original path of / so that we go back to the landing page for now. So I'm going to save this, and we're already running the application. Let's see what happens if we submit an email address here. My email at domain.com. So I'm going to press submit. As you can see, the browser was redirected to the same page, but let's see what happened in our console. We were able to receive the value and print it. Let's check in all the changes we made. So let's go to our terminal and type git add controllers, landing.js, git add routes, index.js, and we also modified our view file. So we're going to do git add views landing.pug and commit landing page post route to submit email. So we're able to receive data in our application, but we're not able to do much with it. So we're going to install a database, an SQL database, in particular a Postgres database for our application. Go ahead and open up your browser and type Homebrew. Homebrew is a package manager for macOS, and one of the packages maintained is the PostgreSQL package. So you can copy and paste this installation script on your terminal if you're on a macOS to install Homebrew. Let's go ahead and just do that. And it's going to install a command line tool called brew, which will allow you to then install various packages, including PostgreSQL. Now I have it already installed, so I'm going to skip this step, and assuming you have installed this. We can then install Postgres by typing brew install PostgreSQL. So after you've done that, you can start your database by typing brew services start PostgreSQL. This is going to start the Postgres process in the background on your machine so that you can connect to it and create databases, manipulate tables, do things with it. So I've already ran this command, so I already have my database running. We're going to use a tool called PSQL to connect to our database and make some changes. So I'm going to type PSQL Postgres to connect. And if everything goes well, you should see the PostgreSQL prompt. And now we're ready to create our database. First, we create a user that can access that database by typing create role Express MVP DB user. I'm assuming here that I'm going to use the name Express MVP for our application. So I'm just adding a dash DB user for that. And with login password, let's make the password simple for now and press enter. And now I'm going to create our database by typing create database Express MVP DB. In case you want to delete these roles or databases and redo the same commands, you can do that by typing a drop database or drop role. So we're now ready with our database. I'm going to quit PSQL by doing a Control D. We're done with our database setup. Now we're interested in using a library for accessing our database from JavaScript and manipulating data. And for this, we're going to use an object relational mapper library, shortly called an ORM. We picked Sequelize as our choice of ORM. If you go ahead and type Sequelize in your browser, you're going to find a website for it. As Sequelize is a stable and popular ORM for Node.js, and it will work well for most of our needs. An ORM greatly simplifies the type of queries you have to write for manipulating database tables and rows. Instead of typing long, error-prone SQL queries, an ORM lets you generate those queries by writing JavaScript. Okay, so let's go ahead and open up our terminal again and type npm install Sequelize. This will install Sequelize as a package. I recommend doing -- save so that it's saved to our package.json file. We're also interested in the database driver library in Node.js for PostgreSQL, which is simply called PG. So I'm going to go ahead and type npm install PG -- save as well. Sequelize will invoke PG in order to access the PostgreSQL database. This is a low-level library for accessing PostgreSQL databases. The other tool that we need is a command line tool for Sequelize called Sequelize CLI. So I'm going to install that as well by typing npm install Sequelize -CLI, and I'm going to use -G. So that concludes our installation for Postgres and Sequelize. Now we're going to create some configuration files so that our application and Sequelize can access our database. And for that, we're going to use the tool Sequelize CLI. But before we start, we need to first create a configuration file for Sequelize CLI so that the default paths we use are going to be defined. Let's go ahead and create a file called .sequelize.rc in the root of our project, typing touch.sequelize.rc. And let's open up our editor. When we open a Sequelize.rc, we see certain paths defined. Let's remove the DB path and let's keep it empty for now. We want to create these directories directly under our application root folder so that they're accessible easier with one less step. So let's go ahead and save this file. And now we're ready to generate some files. So I'm going to type Sequelize init. And we have created several folders. The config/config.js is the one we're interested in. This defines the database details. Let's open up our editor again and go to config/config.js. We have 3 environments defined here, one for development, test, and also one for production. So I'm going to type here module.exports equals, and for development we define the database username as express mvp-db user. As our password we defined 123.456, and for our database these are the users and database we created using the PSQL command previously. So we're going to type express mvp-db. And our host is 127.0.0.1. This stands for the local host. The database we're using is Postgres, so we're going to use the dialect Postgres here. There's one more parameter missing here, the port parameter. Typically for a Postgres database that is 5432. I'm currently not going to touch the other environments and going to save this one here. So we should be now ready to access our database from SQLize using our application. Now I'm going to go back to the terminal to commit some of the changes that we made so far. We installed SQLize and the PG libraries, so we've modified our package.json file. Let's go ahead and create a commit for that change. We have added SQLize and PG packages. I'm going to save this commit. We've also defined a SQLize.rc file, so I'm going to add that one as well and commit this change. Configuration file for SQLize CLI. And I've also created a configuration file for our database connection. So I'm going to commit this file with git add config.js. There's also one more file that I'd like to introduce to you briefly. Under models, when we ran SQLize in it, we defined the file called index.js. This will initialize SQLize when we run our application. It takes the environment that we defined under config.js and then creates a new SQLize instance using the database credentials that we have created. So this is the initialization file that was auto-generated when we typed SQLize in it. So I'm going to check this file in as well. And the file name is always index.js under models, and this is a specific file just for initializing SQLize. So I'm going to commit these changes. So we added configuration file for SQLize and the int script. As a recap for where we've left off, we can visit our landing page and then submit an email address to our application and display the email address collected as a console log. Now that we have installed our database and installed SQLize ORM and configured it, we're ready to define our first model as well as the first migration. So let's go ahead into our text editor and create a new folder called migrations. And let's create a new file under the models directory named lead.js. Since we're collecting sales leads, our table and model will be named leads. Migrations allow us to create recipes to take our database state, the database definition, from point A to point B. For example, right now we have no tables in our database even though it has been created, and with a migration recipe we will be able to create our first table that represents our sales leads, and we will run that migration to create our first table and start accessing it. And the model definition is used by SQLize to generate the methods for accessing the table and to update the table, to take database actions on the table, such as creating rows, deleting rows, updating rows and fields. And in contrast, migrations are used for manipulating the database table definitions themselves, such as creating a table, adding a new column, or changing the type of the column in that table. The migration file that we're going to create is highly specific to SQLize. SQLize has low-level methods for accessing and manipulating a PostgreSQL database, but the migration itself is a file, a recipe that's specific to SQLize, and so is the model that we're going to define. So let's go ahead and create a new migration file, and let's define our first table. I'm going to copy and paste this code that I have already prepared as our first migration. Let's first save this file. Migrations are sequential in the sense that they need to be run in order. They don't make sense if they are run without an order. So we need to order them by the file name, and we do that by including a date starting with the year, a month, and the hour, and even the minute when the migration is created. So as of now, we're in January 4th, 2019. So I'm going to name my migration as 2019-01-04, and then the hour is 1917, And I'm going to include the action that this migration is going to take, which is creating a table named lead. So create lead table, and then finally .js. Here is our first migration saved, and the migrations are bidirectional. So you can apply a migration represented by the up method, and then you can roll back a migration by using a down method. So in this case, the up method stands for creating a new table called leads with so and so fields, and then the down method or action represents dropping the table, will effectively cause the table to be deleted from our database. Now, if you look at the fields that are being generated, we first obviously have an ID field, and ID represents a unique column in our database, and it's represented by a universally unique ID type, and SQLize has that type built in for us. And typically we need a created at and updated at field for each row. When a new row is created, this date will be relevant, and each time a row is updated, this second field updated at is going to be relevant. And finally, the actual field, the data that we were collecting in our application is an email address, so we're including a field called email of type SQLize string. So we have saved this migration. We can go ahead and run it by typing SQLize db migrate. The command has succeeded, which means we have created a table called leads in our database. Now we need to define the SQLize model definition for the table we just created. So let's open our editor and create a new file under models called lead.js. I'm going to copy and paste the definition that I created earlier for this. This JavaScript model file is specific to SQLize. SQLize will generate the methods it needs to access the database table by using this model definition. We define an ID field in the model, which is a primary key, and then we define an email field as well, which is of type string. Notice how these fields match the migration we just ran for the leads table. And we omitted the created at and updated at fields in the model because SQLize assumes they always exist. When we run the application, SQLize will run models index.js. If you look at this for each section, it will go over each model definition under the models directory to import and use for accessing the respective database tables. Under models directory, for each database table, we define a model such as the one we created for lead.js for the leads table, and SQLize will go over each of those to generate the methods so that it can access those tables. In order to achieve this, we need to go to the initialization file bin/www and here initialize SQLize. For that, we need to first create a variable called models and import the models directory, and these three lines start our server listening on a particular port. We're going to modify this code a little bit, and we're going to type return models.sqlize sync and then result. Going to cut and paste this portion inside the body of this call. Okay, we're now ready to further develop our application and run SQLize queries. Before we go any further, let's check in the files that we have just created. So I'm going to add the migration we created and commit this file. Create migration for leads table, for creating leads table. And I'm going to check in the model as well. Git add models lead.js. We're also going to check in the changes we made on the initialization file bin/www. Initialize SQLize in bin/www. Now that we have a database set up, we can implement the post route where we will save an email address to our database. So let's go and open up our editor and go to controllers/landing.js. We're going to modify the submit lead handler to save the email address collected to our database. So let's go to the top and then type const models equals require .. /models. Models gives us access to the sequelize methods for the models that we have defined. And I'm going to type return models.lead.create. Note that create is a sequelize method. And for the email field, we're going to use the value we've obtained from rec body lead email. Then take the result and redirect back to the landing page. And let's delete this last line and the first line. Save and rerun our application. If I go back to the landing page and type an email address here, username @email.com, and submit, notice that the browser reloaded the landing page, and that's because of the res redirect here. And I'm assuming that the create call has succeeded. If you go back to our terminal, we see this SQL statement here generated by sequelize, ran by sequelize. We're inserting a new row into the leads table, in particular the ID email, created that and updated that fields. New unique ID for the row, and then the email address we just submitted, and then the dates. So we've successfully saved the email address in our database. Let's commit the changes we made. So I'm going to type git add controllers landing.js and then commit the change. Save leads collected on landing page. We save email addresses collected back to the database. We're going to implement the most common web development pattern, shortly known as CRUD, which stands for create, update, and delete. We've already done the creation of leads with this route, and now we're going to define new routes that allow us to do listing, editing, updating, and deleting of leads. So, and the first one we will cover is for listing the leads. So let's define a new route with the path /leads and the handler called as show leads. And let's save this file. And let's go to controllers landing.js to define our new handler. Let's copy and paste the first one we created. Let's name it as show leads. Now all we need to do is fetch the leads from the database, and for that we're going to call models lead.findAll, and then we will be returned an object. Let's name it as leads, and let's cut this line with the res render and paste it inside the body here. A few things to note. This call here is a promise, and we're going to cover promises in detail later, but for now what you need to know is that this call is going to execute asynchronously, and the then here ensures that the results within this body are available after the execution of this call has completed. So there's a guarantee that this body is going to be available after this execution, even though the call is asynchronous, and we'll get to those later. And the findAll method is defined by sequelize, and also the leads object here contains the rows returned from the database and also the methods to access those rows. So as you can recall, the render method, the second parameter, is an object passed to our view file. We're going to define a new key here called leads and assign it the value of our object leads, and save this file. And one more thing to note is that this view file, typically we use a different view file for each purpose, but for the time being we're going to use the same landing view file to also show the collection of leads. Now let's go to views landing.pug. We're going to type if leads. Pug will check that if the leads variable is non-zero, it's going to include the rest of the HTML snippet. Let's type if leads, and then let's define a header here called with the text leads. Pug also has the capability of iteration. We're going to do for lead in leads. Note that leads is an array of objects of type lead. We're going to create a paragraph and type lead.email. Now, Pug considers that anything that comes after the P is text. We don't want to display this as text, but we want to use the Pug way of Pug syntax of dereferencing this variable, which we used here, by typing hash open curly brackets and then close curly brackets. So let's save this landing file and go to our terminal. Our application is still running, so let's go to our browser and type localhost 3000. There's one more thing we want to do. Let's go back to the landing.js controller. Now, instead of redirecting to the slash route, we actually want to go to the leads route when we submit a new lead. So that's the change we make, so that this new route that we defined is going to be triggered, which will call this show leads function. Okay, so if we go back to our browser, let me submit a new email address, lead1email.com, and when I submit this, I see the list of leads on the same page. And notice how the browser went to the slash leads route because of the change we just made. So let's check in the changes we made. So I'm going to do git add controllers, landing.js, git add routes, index.js, and add views landing.pug. Implement leads route, show a collection of leads upon submission. Now we want to take a look at the details of each individual lead. So let's define a new route called /lead/ lead underscore ID, and let's define a handler landing.show_lead. Now, two interesting things here. Firstly, we defined /lead/ as a unique path component to match individual leads. And notice how this path is unique and different than the other routes we defined. We will handle all details of an individual lead under /lead/ path component, which gives us sort of a namespace to work on individual leads. The colon here defines lead ID as a parameter, as a request parameter. That means whatever that comes in the URL you type in the browser after /lead/ is going to be captured in a request parameter named lead underscore ID, and we can then access the value of this parameter in the root handler show lead. Now let's go to controllers landing.js and copy and paste one of the handlers we already have. Let's name it as show lead, and what we need to do now is query the database for a lead with a given ID. So I need to do return models.lead.find1, and then the where clause helps us query for a particular field, and we're going to use the ID field, and we're going to pass the request parameter that we received named as lead ID to find the particular lead record in the database corresponding to our lead. Now this will return a lead value. Let's go ahead and delete this portion, and here we're going to do render. We're going to define a new view file called lead and pass an object with key lead, assigning it the database object that we received. Now let's save this file and go ahead and create a new file under views called lead. Let's copy the initial portion of landing.pug, and let's define an h1 lead header, and let's simply define a paragraph with the lead information lead.email. Now let's go to landing.pug. We want to give the user an opportunity to click on a link that takes us to the individual details page for that link. And we don't have that link here, so I'm going to add that to this paragraph. But I would like to display both the lead email and also that link on a single line, the same line. So I'm going to nest the link and the email under the same paragraph. As a reminder, we nest HTML elements with indentation in Pug. So I'm going to first define under the paragraph a span element that will display our email, and also this character that I'm typing is used for text and also to display spaces in Pug. So I'm going to include one space character and define our link with the anchor tag with an href property of /lead/. And now here we already have access to the lead object that has been obtained from the database. So we can include the ID of the lead here by typing lead.id, and we are going to use the text details in the link. So now this link is going to point at the path /lead/ plus the database ID of the lead. So let's save this and run our application. Everything seems to work fine. So let's open up our browser, type localhost 3000. Let's submit a new lead at domain.com, and see that we're able to display both the leads and also the details link for those leads. I'm going to click one of them. We're now navigated to that path, and we're able to display the lead information. Now let's check in all the changes we made. Git add views, git add controllers and routes. And then if we commit now, add a new route to display lead details. Let's go back to routes/index.js, and we're now going to define the routes for editing individual leads. So let's type router.get/lead/lead_id, and we're going to define a new action for this particular lead ID, which is going to be /edit, and we're going to define a new handler with landing.showEditLead. Now this is a get route, which means that we're going to fetch a new web page for the purpose of editing the lead ID. So we're going to deliver a form that contains information about this lead ID by using the showEditLead handler. And let's type router.post/lead/lead_id/edit and define a new handler called edit_lead. Here, the first route we define shows the form for editing the lead ID, and the second route we defined, which is a post, submits the form to edit the lead ID. Now, there's one key point here. We are highly interested in defining the same path component for the get and the post routes. And this is because on an error when we handle the post request, if we re-render the same page, we want the URL in the browser to match the original GET request. We're going to go into more detail about this when we cover error handling. Now let's get started by creating the link that will take us to the edit route for the lead. For that, let's open up views lead.pug. Now we're going to modify this by creating a span under the paragraph, and we're also going to create a link, an anchor tag with an href of /lead/ plus lead.id. Remember that we have the lead database object available to us, so we can reference its ID. And also we're going to add the /edit path for editing the lead. Now let's write edit for this link and save this file. And notice how the value of this href property corresponds to the get route we defined here. Now let's define the handler for this show edit lead route by going to controllers and landing.js, and let's copy and paste one of the handlers here and call it show edit underscore lead. Now this handler also obtains one lead record from the database by using the lead ID parameter, and then we're going to, instead of displaying the lead, we're going to display a form where we can edit and submit the updates on a lead. So I'm going to call this edit underscore lead, and we're going to use a directory called lead for all the view files where we manipulate each lead. So I'm going to finally call this lead/edit.lead. Now let's save this controller and create a subfolder under views called lead, and also create a new pug file called edit underscore lead.pug. Now let's go to landing.pug and copy the beginning portion to edit lead. And now we're going to create a form under edit lead where we will have the opportunity to modify the lead. So we can copy some code from landing.pug where we already had a form. I'm going to copy this form and input element and the button element to edit lead. Now the action for our form needs to reflect the route that we defined here, which is lead/leads and then the lead ID and edit. So let's go ahead and add that here. We're going to use plus lead.id and then plus/edit, and the method we're using is a post method, and we're still going to use the same name as lead email in our input. It is of type email. If we need, we have a placeholder if the lead field is empty. And then let's call this button save. Now, rather than an empty form, we want to show the existing value of the lead. So we're going to add a new property in our input element called value and assign it with lead.email, which we will receive from the database. Now let's save this file. Because this file is one subdirectory under views, because we created this lead directory and we are referring to layout.pug at the beginning, we need to update also our reference to go one directory level below. Now if we go back to our index.js file, we haven't defined the root handler edit underscore lead for the post route. So let's go to our controllers landing.js and define a new route called edit lead, and let's delete the body. Now we have access to the lead's ID by using rec.params.lead underscore ID, because this was available to us in the route path. We also have access to rec body lead underscore email, the actual updated field, and that comes from the edit lead form. The name of the input element was lead underscore email. So we're going to use these fields to first retrieve the object by using its ID, and then we're going to update its email field by using lead email. Let's go ahead and type return models.lead.update email rec body.lead underscore email, and we're going to use a where clause. We're going to ask for the ID field using rec params lead underscore ID, and our query is complete. Then once this field has been updated, we're going to receive the results as how many fields has been updated from SQLize. We're going to redirect the user to view the lead. So we're going to use /lead/ plus rec params lead_id. So this way, after the post is successful and update is done, we're going to be redirected to this route that shows the details of the lead. Now let's save our controller and run our application and see how it works. So I'm going to open up the terminal. The application seems to be running okay. And I'm going to open up the browser and browse to localhost 3000. Let's create a new lead, hello@getbuzz.io, and submit that. So we have a collection of leads displayed. Let's click on one of them and click edit. We're now on the edit route, and I'm going to shorten this to, let's say, a@b.com and save it. And I'm redirected to the show lead route that shows the updated leads. So this concludes our tutorial on editing and updating leads. Now is the time to go back to our terminal and check in the changes we made. So I'm going to type git add views, git add controllers, and git add routes. These are the directories that we modified, and then we're going to commit. Add lead, edit, and post routes. The next route we're going to implement is the delete route. Let's go back to our editor, routes/index.js, and create a new route. router.posts/lead/lead id/ we're going to use the delete path components, and then let's define a new handler called delete_lead. Let's save this file and then go to controller/landing.js, and let's create a new handler for the delete action. Let's call this delete lead. We're going to delete the row in the database representing this lead. So we're going to type return models lead destroy, where id is rec params.lead_id. Then redirect back to the landing page, because we're going to delete the current lead and everything associated with it, including the page that shows the lead. So let's type res.redirect/leads. Now let's save this file. So let's go to views, lead.pug. Let's define a new action here. We're going to use a button instead of a link, because the default method for accessing a link is a GET request, but we're interested in doing a POST request. So I'm going to define a form here. Action will be /lead/lead.id/delete, and method will be post, and we're going to have a button of type equals submit, and we're going to call the button delete. Let's also create some spacing, and we're now ready to run our application. Let's go back to our terminal. The application is running. Let's make sure we've saved all the files and try it. Let's go to /leads. Let's go to the details of the first one. We do have a delete button. Now let's click on it. The entry was deleted. Let's try it again. Okay, this one was also deleted. Let's take a look at our database activity. We're deleting from leads, where ID is this ID. This concludes our implementation of the delete route. As usual, let's check in the changes we made. I'm going to do git add controllers, git add routes, git add views, git commit. implement delete route for leads. In this tutorial, we're going to learn how to implement AJAX requests and get started with using JavaScript in the browser. We're going to implement the delete lead functionality using client-side JavaScript. So let's start by defining our routes with router.post /lead id delete, and we're going to name this as delete-json, and we're going to define a new handler, delete lead json. Let's save this file and go to controllers landing.js. We're going to copy the delete lead handler we created previously, and we're going to name it as delete lead _ json. We're still going to destroy a lead using the request parameter lead id, but then after that, instead of redirecting to the /leads route, we're going to send back a JSON object, and we will do that by typing res.send, defining a key MSG with the value success. Now let's save this file and go to view/landing.pug. We're going to implement a button that will invoke the AJAX request that will delete the particular lead. So let's define a button with the text delete, and we're going to define the onClick property of the button to call the JavaScript function delete lead. OnClick is an event that gets fired in the browser when this button is pressed, and by assigning it a handler, we make sure that when the button is clicked, this JavaScript function will get called. Now, when we insert inline JavaScript like this inside Pug, we surround it with this character called the grave accent, which looks like this tilted single quote. We're also interested in passing this lead.id field to the delete lead function, but also we want Pug to evaluate the value of it and pass the value. And in order to do that, we type $ and then curly braces lead.id, and we surround the result with single quote character. Now I know this syntax looks a little bit complicated, but this is the best way to add inline JavaScript in Pug, also passing variables that need to be evaluated. For those who are curious, grave accent is this left tilted single quote. Now for the implementation of delete lead, we're going to use the jQuery JavaScript library, so I'm going to include that at the bottom of the HTML page with this single line. We're also going to add a JavaScript file that we are going to define as javascripts/leads.js. So let's save this file and go to javascripts/leads.js. Now let's define our delete lead method and go over the details. This delete lead function is making an AJAX call. AJAX allows us to make HTTP requests to our web server using JavaScript, also sending and receiving data in form of JSON objects. The key point with AJAX is that the requests, the web requests, happen in the background while you're on the same web page. So if we go back to our browser, let's assume that I clicked on this delete button and it invoked our function that makes the AJAX call. That means that we're still going to be on the same page, and this URL here is not going to change, and the request to our web server and the response will happen in the background. Now let's take a look at the parameters we pass to this function. The URL field defines the route that we're going to call, and notice how this path matches the route that we've defined for this purpose. We have a data type as JSON, and then we typically pass the data payload in this data field, and JSON.stringify function is called to pack the data into a form that's transmittable over the network. And then it gets unpacked on the other side using another call that matches this, which is JSON.parse. The type of our request is a post request, and then we define two functions, one for the success case and one for the error case, and these get called when we receive a response from the server. When we delete the lead from our database using the AJAX call, we want to reflect that the lead is removed to our user on the browser window as well. Now recall that we did not navigate from the current URL and the AJAX call happened in the background. For that reason, we need to modify the currently served HTML page we're displaying in the browser. We do this dynamically in JavaScript and delete the HTML that corresponds to the lead that we have deleted. The currently served HTML document visible in the browser is shortly called as DOM, which stands for Document Object Model. Now, jQuery has convenience functions that help us manipulate the DOM, such as this remove call. In this first part here, we're looking for an HTML element with the ID of lead ID, and then we're making a call to remove it from the currently shown HTML document. Now, in order for this to work, we need to assign the lead ID to the particular HTML element we want to delete. So for that, let's go to views/landing.pug to this paragraph element. For each paragraph we create for an individual lead, we're going to assign it the corresponding lead ID. Now, HTML documents are hierarchical, and what that means is that this paragraph is a parent of all of these children that have been nested inside it. So if we delete this paragraph element from the HTML document, that effectively means that we're also deleting all the children, which includes all the details for that individual lead. So we're going to delete this whole thing by simply searching for the paragraph element with the lead ID and then remove it from the HTML document. And that's effectively what this call is doing. Now, a few useful details about jQuery. When you see a $sign like this, it means that we're making a call to jQuery. It just means we're making a library call. $.ajax means we're calling jQuery Ajax, and this dollar and then the parentheses mean whatever that's inside is going to be handled by jQuery. The second detail I want to mention is this part here. When you use this hash character, it means that you're simply searching for an ID in the current HTML document, the DOM. When we do hash plus lead ID, it means we're searching for the elements with that particular lead ID. jQuery will go and search for every element that has an ID property defined, which is a fast way of searching for elements in an HTML document. Now, let's take a look at how our application works. Let's go to the /leads route in our browser and click on the delete button on some of these leads. As you can see, the leads are being deleted from this current HTML page, but let's see what happens in the background. So I'm going to open up the JavaScript console to see if we're getting results. So if I open up these result objects, I see that the message success has been received from our server each time I delete an object. Let's try it once more. And also, let's take a look at what happened on our server side. As we are seeing, we're doing a post request to the delete JSON route, and also we're able to delete leads from our database. Let's check in the changes we made. I'm going to do git add controllers, git add routes, git add views. We've also defined a new JavaScript file, so I'm going to do git add public JavaScripts. Let's commit this. Implement lead delete route using Ajax. In this tutorial, we're going to update the looks of our application using the Bootstrap CSS framework. So let's open up our browser and search for Bootstrap. And click on this link and go to getbootstrap.com. The easiest way to include Bootstrap in our project is to include hosted CDN links of the library in our project files. CDN shortly stands for Content Distribution Network, and there are third-party hosts for JavaScript libraries, and we will copy and include the links for Bootstrap library in our project. And for that, let's go to this link and click on the latest version and click on download, and if we scroll below, we're going to be given the links to the Bootstrap CDN. Let's copy and paste them in our project. There are also dependencies provided, so let's copy and paste them as well. Now in this tutorial, we're also going to learn how to separate our PUG files into reusable components. And we're going to create a header, a navbar, and a footer component that we can use across all of our files. Let's create a new folder under views called common. And let's create new files, head.pug, footer.pug, and navbar.pug. Let's go to head.pug and type mixin head title indent head meta charset equals utf8 and title equals title. Pug mixins allow us to define common snippets and include them in multiple pug files. We can also pass them parameters such as this title field that gets used as the title of the document. Let's go back to where we copied the Bootstrap style sheet link, cut it and paste it on head.pug and change the syntax to pug, which is link, open parentheses, some properties, and then close parentheses. We also need to add some standard meta tags in our head section, so let's do that as well. Now let's save this file and go to footer.pug and type mixin footer footer. For the time being, we're just going to include the JavaScript files. So let's go back to where we copied the Bootstrap JavaScript files, cut and paste them on this file. We're going to change each script tag syntax to use the pug syntax, which is script, and then open parentheses, some properties, and close parentheses. Now let's do this one as well. Now the order that these libraries are declared matter, and Bootstrap depends on these other libraries, so they need to be declared before the Bootstrap declaration. So let's go ahead and fix that order. We're now ready to include our header and footer in landing.pug, so let's go there and delete these first few lines and type doctype HTML lang equals en, and we're now going to include common head.pug, and we're going to invoke the mixin by typing head, and let's give it a title starter MVP. We need to add a body tag, and let's indent everything to nest in the body, and then at the bottom, just before leads.js, which depends on jQuery, I'm going to add the footer. Include common footer.pug and invoke the footer mixin. And we don't need this line anymore because we've declared jQuery in footer.pug. Now let's save this file and reload our landing page. We can see now that this is a Bootstrap enabled page. Now the page elements look rather plain because we didn't add any styling yet. Let's conclude our tutorial by doing some maintenance work. The other pug file that we used was lead.pug, so let's do the same thing on that file as well. We're going to copy and paste this header section. We're going to add a body. We're going to indent the body to nest it under the body elements, and we're going to copy the footer section. To be nested inside the body, and save it. We also are not going to make use of this layout.pug file anymore, so we can delete that. Let's check in all the changes we made. I'm going to type git add views common, git add views, and git commit. Add a common header and footer section in all pug files. In this tutorial, we're going to focus on the user interface and update the looks of our landing page using Bootstrap templates. Let's open up our editor and go to views/landing.pug. Now under the body, I'm going to copy and paste a Bootstrap navbar example that I've prepared earlier. This is our navigation bar. Typically for a functional component of a page like this, such as a navbar, we can take a look at an example on the Bootstrap website and copy it. Now, when we define components in Pug, the first element you define is the HTML element, and then everything that comes after that, separated by a dot, are CSS classes. CSS classes modify the appearance of your HTML elements. So in this navigation bar, we're first defining a link, and then we're nesting an image in it, which is going to serve as our logo. And then we have two navigation links nested in an unordered list. Notice how each HTML element has a different CSS class. These are classes defined by the Bootstrap framework and available to us. One last point here. Notice how we define these HTML elements in Pug, but this line does not contain a beginning HTML element, and that's because this is typically considered to be a div. You can type it like this, or you can omit it, and it will be assumed that the first element is a div element. We're also making use of an image asset file. For that, I copied the file under public/images/file name. All your assets, which are shortly static files that never change in your application, are stored under public. You can refer to an asset file in HTML by starting with a slash and then the folder name and then the file name. So as the root of your asset path, slash refers to your public directory. Let's try and run our application by reloading our homepage. Now we see a navigation bar, two links, and a logo. Now, as we did previously, I'm going to cut this navbar from here and place it in a common mixin file. So let's go under views/common/navbar.pug we created earlier and paste this code. We're going to define a new mixin called navbar, and currently we're not needing any arguments. And I need to indent this by one level under mixin and save the file. Now let's go back to landing.pug and include our mixin under body. We first need to add a header tag, include common/navbar.pug and then plus navbar. And let's update the rest of our page using Bootstrap HTML elements. I'm going to type container and we create a new row, and then inside the row we create a new column, and the size of that is 6 for a medium-sized screen. We're going to copy and paste a header and a paragraph or two for our value proposition. And let's delete these two lines here. There were a few CSS classes that were previously prepared. I'm going to copy and paste those. And we have a form snippet as well that matches the form we created before. Let's copy this portion, the contents of the input element. And let's delete this part. Now let's save this file and reload our page. Now we have a landing page that has an updated look. Let's go back to landing.pug and we're going to update the portion where we list the set of leads. For that, I'm going to create a new row and then a column with an MD-6 type. We're going to indent this portion. And I'm going to replace this portion with a table. So let's go ahead and do that. Now, if we reiterate on this source code, if there's a variable called leads, we're showing the title leads, and then we start a table. Inside the table, under this t-head element, we list the names of the columns for the table. We're using the name email for the email field and then the actions. Under the t-body tag, we're listing the rows for the leads. So here, for each lead in leads, we're creating a new row, and then we're listing the email for the lead and then a link to the details, also the delete button for it. Notice how we moved the lead ID as the ID property to the table row so that the delete lead call can find which row of the table to delete when it's deleting the lead. So as a recap, if we go under public JavaScript leads.js, this line will find the right HTML element and then remove it. And in the case of a table, this is the table row. You can check out the Bootstrap documentation on how to build tables like this. Now I want to make a few fixes on the indentation. Under this h1 tag, we're nesting this table, and that's not correct. So I'm just going to denest it by one level. Also, we want to nest this row under the container tag. So let's go ahead and do that. That's done. Let's save this. Now a few more changes. Let's go to navbar.pug. I want to update the link to the leads route. And also let's go to footer.pug. Remember, when adding a dependency for the Bootstrap library, we added this jQuery 3.3.1 and then the slim version. Turns out the slim version does not have AJAX calls, so we won't be able to make the AJAX call under this delete lead function. So I'm going to go back to this and delete this slim portion, so we're now referring to the full version of jQuery that includes the AJAX calls as well. We need to delete this integrity hash as well, since this was referring to the previous file. Let's save this, and we should now be ready to run our application. Let's go to our browser and reload the home page, and let's click on the leads link. And if we go down below, we see all the leads listed, and let's click one of the delete buttons to delete them. Before we move on, let's check in all the changes we made. So I'm going to do git add views common, git add views landing.pug, and let's try doing git commit, and let's type install bootstrap and update the look of pages. While we're at it, I want to organize our pages under the lead directory, and I want to remove the list of leads from the landing page and create a dedicated page for leads. So let's go under lead and create a new file and save it as leads.pug. We're going to copy the first portion of our landing page. Let's just copy this part and paste it here. Also, let's copy the footer part and paste that as well. And in this middle section, we're going to create a new container and then a column. Let's copy and paste those. These are nested under body and header. And let's cut and paste the section for leads. We're actually not going to use these two lines in the landing page either, so let's delete those, save it, and under leads I'm going to paste the section. We don't need this if leads check because we're already displaying a page. And let's save this file. Now let's go to controllers landing.js. Once we submit a lead, we're redirected to the leads route, and once we show the leads, instead of using the landing page, we're going to use the new page we defined, and that'll be under lead/leads. And let's save this file, and let's go ahead and run our application again. If I reload this page, I got an error because the head file is located under common, and I am one directory level below with the leads.pug file. So I need to type .. for all the common files. Let's save this file and reload our application again. And here we are on the leads page. We can now see the leads on a separate web page. Let's also update the title here to leads. And I'm also going to move this lead.pug file under the lead directory. So let's just do that. Move views lead.pug, views lead.pug. And I'm also going to update the CSS classes here to match the ones we used under leads and to use Bootstrap. So let's copy and paste the code we have for leads.pug into lead.pug. And let's take the section that lists the single lead, and let's delete the rest. Assuming that we are going to use a table, we can update the contents of the table to match a single lead. So instead of having for lead in leads, we're just going to access the lead we have. So let's do this. The first field is the email field, which is the same here. We can change this as edit and then delete. And here we're going to have edit plus /edit. And instead of the Ajax call, we were going to use this form. Let's copy and paste that. And as you might know, we're using the button, using the Bootstrap CSS classes. So let's double check what we're doing. The first entry is lead.email, and the second entry is the link to /lead/lead ID and then edit, which matches the link we created here. And then the last one is a HTTP post when we submit with this button, and the path is /lead/lead ID delete. So let's delete this portion and the body. Let's save this file and let's go to controllers landing.js. When we render the lead page, that is now located under lead/lead. Let's save this and run our application again. So I'm going to go to the browser window. If I click on the details, now I am seeing the lead page. It now has the Bootstrap classes and a table. We need to redo the same exercise with edit lead.pug, although I'm going to copy and paste code I prepared earlier because it's repeating the same exercise. So let's delete this HTML and paste. This concludes this part of our tutorial. We've migrated all of our pages to Bootstrap and also created a separate leads view file. Let's check in our changes. In this tutorial, we're going to develop sign up and login functionality and learn how it all works. Let's open up our editor and open routes/index.js. We're going to get started by defining the routes for login and sign up. So let's type router get/login. We're going to use a new controller called user, and we're going to use a handler called show login to show the login page. And then we're going to have a router.get for sign up. And again, we're going to use the user controller and type show sign up. Now let's define our user controller here as well. So I'm assuming we're going to define a controller called user under controllers, and let's save this file. And let's go to controllers, create a new file called user.js. I'm going to copy and paste code that I prepared earlier. Nothing much happening here. We're simply showing the login page. The view is located under user/login, and then we're showing the sign up page with a sign up view under user directory. We're also passing two objects to the view file. One is form data and the other one is errors. We're going to get back to these later on. For now, let's know that we're simply passing empty objects. Because these views are located under the user directory, let's go ahead under views and create a new folder called user. And I'm going to create two new files called login.pug and signup.pug. Now let's define these pages. I'm going to paste some code that I prepared earlier for this. Nothing much interesting happening here since we covered Bootstrap a little bit before. But the essence of this page is that we have a form that posts to the sign up route, and we're placing two input elements here. One is an email and the other is a password, and we're submitting them with the submit button, and then we have a link at the bottom for the option of going to the login route. Now let's go to login.pug. Also, I'm going to paste code that I prepared for this. It's essentially the same code, except we're posting to the login route and we're passing an email and password field as well, and the purpose of this page is to log in. And then we have two optional links at the bottom. One is to reset a password. We haven't got a route for that yet, and then we can go back to the sign up route. Let's save these files and go to our browser to take a look at how they work. So this is how our login page looks, and if I click on the sign up route, this is going to serve as our sign up page. Now is a good time to define our user model and migration of our database. So let's go to models and create a new file called user.js. Since we covered one model definition in detail for lead.js before, I'm going to paste code that I prepared earlier for the user model definition, and let's go over it quickly. So we're defining a new user model, we're defining an ID, and then we have several fields of type string. We have a username, first name, last name, password, and email. Now, we're not going to make use of these first three fields, so we're passing a property allow null true so that we can create rows that have null values for these fields. And we're essentially going to make use of the password field and the email field. And we're also passing the property unique for email as a constraint so that each unique user is distinguished by his or her email address, and email is a candidate key for this table. Now we need to create a database migration that matches this model. So let's go to migrations and create a new file. And I'm going to name this file with today's date so that it goes in the right order in terms of migrations and comes after the lead table migration. Let's save this file. I'm also going to copy and paste code to go faster since we've covered a migration example before. So as we covered previously, the migrations have two methods. One is an up method to move the table definitions into a new form, and then a down method that rolls back the change that's being made. In this migration, we're creating a new table called users, and the fields we're creating match the fields we defined in the model. Nothing surprising or interesting here. Let's save this file and go to our command line to run this migration. I'm going to type sequelize db migrate. Our migration has succeeded, so we have created this table in our database. And before we move on, let's check in the changes we made. So I'm going to type git add views user, git add controllers, git add routes, and git commit. Implement get route for login and sign up. We're also going to check in the migrations and models. So for that, let's do git add models and git add migrations, and git commit create user model and migration. Now let's open up our editor and go to routes/index.js, and we're going to define the post routes for login and sign up. So let's type router.post/login user.login router.post/signup user.signup. Now before we move on, let's define these controller handlers as well. So let's go to controllers users.js and create these two empty handlers, sign up and login. Now we're going to implement the sign up and login routes using a Node.js library called Passport.js. In particular, Passport.js helps us with implementing authentication. As you might guess, there are many ways to authenticate your users. You could use social networks or other means, multiple methods of authentication for us. And if you're interested to find out more, you can go to passportjs.org for more details. Now let's go back to our terminal to install the packages we need. Let's type npm install Passport. We're going to use an add-on to Passport for local authentication to our database. So for that, let's type passport-local. We're going to use a library called bcrypt for encrypting our password. And we're going to use the package validator to validate the input we make on login and sign up routes. We're also going to need to create sessions for our users. So let's type express-session. And finally, we're going to display error messages if login or sign up fails for any reason. And for that, we're going to use a package called connect-flash. So let's type --save and press enter. This might take a while because we're installing multiple packages. And let's check in the changes we made. So I'm going to type git add package.json, git add package lock.json, and commit express session and connect flash. Now let's go back to our editor. We're going to go to app.js to create an instance of passport. So let's type let passport equals require passport. We're also going to define the session. So let session object equals require express session. And let's go down below. Right after this line, we're going to declare app.use session. We need to define a secret parameter for this. Let's just type our new secret for now. And in the second line, we're going to type app.use passport.initialize, and finally app.use passport.session. Now, each of these calls must be in this given order, otherwise your application may not work. Because when app.js is processed, it goes line by line to configure the app instance in a sequential order. So that's why we need these 3 lines in this order. Now, we're interested in setting up Passport in a separate file than app.js in order not to clutter app.js with details of Passport.js setup. So for that, before we create the app instance, we're going to add one more line here. We're going to type require./passport setup, and we're going to pass the passport object. Now let's save this file and create a separate file in our root directory called passport_setup.js and save it. Now in passport setup.js, we're going to start by defining an empty function that we're exporting from this file, and we're passing the passport object to it. As you might see here, we're also calling the same function with this require statement, and we're passing the passport instance we created a few lines earlier. So let's go back to passport.setup. Now, passport.js requires us to define a few well-defined API calls to function properly. The first function is called serializeUser, and the second one is called deserializeUser. This Stack Overflow page explains it quite well. SerializeUser is used by passport.js to save a handle to the user object. In this case, it's the database ID for the user. It's then saved to a session variable, and later on, deserializeUser will use this handle to retrieve the actual database object for the user. User object is then assigned to the user key of the request object so that we can use it in our controllers or routes. So let's go back to passport setup.js and define these functions. For serializeUser, we're going to simply use the database ID, and for deserializeUser, we're going to query our database. We'll pass the ID to our user, and then we're going to type models user find one, where ID is the ID parameter, and then we get the user object back. If user is null, it means there's an error, so we're going to throw an error object, wrong user ID, and else we're going to call done null user with the user object. So we're almost done. As a recap, serializeUser function determines which handle to the user object is to be saved in the session, and then the deserializeUser will retrieve the user object using that handle. Now we need to define a strategy for passport.js to use to authenticate our users when they log into the application. Because we're going to use email and password as the method for authentication, we're going to define what is known as a local strategy for Passport to authenticate our users via email and password. Now let's go ahead and type let local strategy equals require passport local. This is where this package comes into play. And then we're going to type strategy. Now we need to tell passport.js that we will be using the local strategy for authentication. For that we add a statement passport.use new local strategy. Local strategy will call its authentication function when there is a login form submitted via a post request. So local strategy needs to know which fields in the submission contain the username and password. For that there are 2 optional fields to define these. Username field, in our case it is called email, and password field. and in our case it is called password. Now if you go to login.pug, you will see that the first input field is named as email, which we will use as the username, and the second one is named as password. So when the local strategy accesses request body email, it will consider that as the username, and then when it accesses request body password, it will assume that to be the password field. Now we need to define an authentication function where we access the database and show that there is indeed a user with this email address and the password provided. We type function email password and done. Now this function will authenticate the parameters. However, we also need the request object here. And in order for passport to pass us the request object as the first parameter, we need to give it another option called pass rec to callback true. We're going to use this for error handling later on. Now let's define our function. Let's open our curly braces and type return models user find one, where the email field is the email parameter, and then we will receive a result which let's call as user, and if this user is null, it means we couldn't find the user, so we're going to return an error message incorrect credentials, and we need to add return done null false, and we're going to type else if user.password is null or user.password is undefined, rec flash message you must reset your password. These rec flash messages will be shown in the subsequent re-render of the page, and we're also going to type return done null false. This is another error case. Finally, else if, we're going to define a function that validates the password provided is correct. So let's call that valid password. We're going to define it shortly. We're going to pass the user object and then the password provided in the login form, and let's type rec flash message incorrect credentials, and this will be entered if the password isn't valid. So I'm going to add a not, and here we're going to type return done null false. So we've handled all the error cases, and if we have a valid user, we're going to return done null user. There may be further errors other than incorrect credentials being provided, and we will handle them with this catch statement in the end. For example, if there was a database error when accessing the user model, that will be caught by this statement. So we're going to type catch error and done error false. Now let's save this and let's go ahead and define the valid password function. For password validation, we need bcrypt library. So let's type require bcrypt. Actually, for accessing the models, the database, we also need to define the models variable by typing require./models. And we're going to compare the past password versus the one in the database. So let's type valid password equals function user password, and then return bcrypt. Compare sync is a bcrypt function. We will pass the password in the login form versus the user.password field. Now the passwords contained in our database is a hash of the provided password so that we don't keep them as clear text. So this function will also convert the password to a hash and compare the hash value to the one that's being stored in the database. This way, if the database was compromised, the adversaries cannot access the clear text passwords, but they only get access to the encrypted versions. We're done with the implementation of our first passport login and sign up strategy using the local strategy, and let's go over the API calls again. So we're providing passport with a handle to the user object, which is to be saved in the session, And then Passport.js will use this handle to get the actual user object from the database. We also define a local strategy where we tell Passport.js what fields to use for the email and password fields when authenticating the user post request. During authentication, there may be various errors. Once the database is queried, given the email and password fields, there may be multiple authentication error cases. One of them is that the incorrect username is provided, the password field is not present, or the password is simply not valid. In such cases, we return an authentication failed message back to the user. In the successful case, we pass the user object to the done callback. And we also catch database or other internal server errors with a catch statement. We use a valid password function call to compare the passed clear text password with the hash that's stored in the database. We're now ready to check in our changes. So let's go back to our terminal and type git add app.js, git add passport setup.js, and git commit -a. Implement passport local auth strategy using email and password fields. Now that we have set up Passport.js, we can go ahead and use it in our sign up and login routes. So let's go and open up controller/user.js. In the sign up handler, we're going to create a new user by using the user model and then save it to our database. So let's type const new user equals models.user.build email rec body email and password. We're going to use a function to generate the hash of the password. So let's call this function generate hash, and we're going to pass rec body password. Once we build the user object, we're going to save it by typing return new user.save, and this is a promise, so we're going to do then result. And inside the body of this promise, we're going to make a call to Passport.js to authenticate the user after signup. So let's call passport authenticate local, since we are using the local strategy. And then we're going to define a redirect route after the authentication. So let's type success redirect / failure redirect, which is used upon the passport authenticate call failing. We will call /signup, and we're going to define a flash message, failure flash true. We're also going to pass the request, response, and next objects. Now, in order to use the models object, we need to first define let models equals require models. And let's define the generate hash function, const generate hash equals function password. And in the body, we're going to use the bcrypt method hash sync. So return bcrypt hash sync password bcrypt again salt sync 8 and null. So generate hash function will take the password and create a salted password. What that means is we're going to create a hash of this password and save the hash in the database. Now let's also define the bcrypt object. Let bcrypt equals require bcrypt. Let's also define passport equals require passport. We also need to set up passport, so let's type const my passport equals require passport setup, and we're passing the passport instance. We also will need flash, so let's type let flash equals require connect flash. You might be wondering what flash stands for. Flash allows us to display an error message on the page that's going to be rendered. So it's a one-time message that we can send to our client. Now let's save this file and run our application and verify that the signup works. I'm going to run the application, go back to the browser and type /signup. Let's type user@email.com and then a password and press sign up. Now that we've been redirected to the / route, it seems to be working. Let's go and verify this by going to our terminal. Here we're inserting a new user to the database with the email that I have just typed. We have also started a new session with our application. Now let's go back to our editor and implement the login route. In login route, we authenticate a user and initiate a session with our application. For that, we're going to do the identical action as we did in signup with Passport. So I'm going to copy and paste that code. The only difference being here is that upon failure, we're going to be redirected to the login route. Let's check the result by going back to our browser. And let's type /login. Let's type user@email.com and then the password. And I'm going to click on login, and I'm redirected to the / route, which means the login was successful as well, and I've initiated a session with my application. Now let's go back to our editor, routes/index.js, and for completeness we're also going to define a logout route. So let's type router.post/logout user.logout and router.get/logout user.logout. For both requests, we're going to use the same method. Now let's go back to controllers user.js and define a new method called logout. We can destroy our session by making a call to rec logout and rec session.destroy, and we will then redirect the user with res.redirect back to the root route. Now it will help us to display these routes as links in our navigation bar. Also, we want to know whether we have a user session or not. So let's go to views/navbar.pug to implement this. I'm going to paste a snippet that I prepared earlier. Here, if we are passed a user variable, that means we have an active session going on, and we display that by showing hello user email on the navbar. We also have links to logout, login, and signup routes. Now for this user variable to be passed, we need to define it as an input to the navbar mixin. So let's type user and save this file. And navbar is used from the landing page. So let's go to views/landing.pug and pass the user variable to the navbar mixin. Let's save this file, and now let's go to controllers/landing.js. We're going to pass the user variable to the render function. So let's type user rec.user. If you recall, Passport.js will populate this rec.user field with the user object if there's an active session going on. Let's go to our browser window to test the login and logout routes. Let's go to login and type user@email.com, password, and login. As you can see, we have logged in and we can see the user information here. And let's click on logout. And now the user session is destroyed, so we don't see the user email address here anymore. Now let's go back to our terminal and check in all the changes we made. If we type git commit-a, it will include all the files that have been modified. Let's type implemented signup, login, and logout routes using Passport.js. In this tutorial, we're going to learn how to validate form input when a form is posted to our server and how to re-render the page with error messages when there are errors. As a recap for how we handle form submissions, let's open up our editor and go to routes/index.js. Here we have defined a post request handler for signup path using this user.signup handler. So let's open up that handler by going to controllers/user.js. If we look at the signup post handler, we see that we create a new user object without validating the input we receive from the form. Rec body email and rec body password fields are used directly to create the user and save to the database. We're going to change that and validate these input fields first before saving the data. And for that, we're going to define a validator function for our form input. So let's get started by installing the validator package by typing npm install validator. We are also going to use a package called lodash, so let's add that as well and type --save and press enter. Let's commit our package.json just in case we made any changes. So I'm going to type git commit package.json and package lock.json. Okay. Update install validator and lodash. Now let's go back to our editor, and in the root directory my app, let's create a new folder called validators and save that. And we're going to create a new file called signup.js. Here let's type let validator equals require validator. Save that. And I'm going to create a local function const validate create user fields function. This is going to receive an errors object that is empty, and we will populate it as we find errors in each form input field. And we're going to receive the form input fields with the rec parameter, which is the request object. So let's type if validator is email rec body email. Here this mark stands for not. So if this input is not an email, then we will populate the errors object with the key email with a message, please use a valid email. So we're going to go over each input field like this with an if statement. So the next one for us is if not validator is ASCII. We're requiring that we want the password to be made out of ASCII characters, and we're going to pass the password with rec.body.password. If this doesn't hold true, then we're going to populate the errors object with the password key to be invalid characters in password. Please try another one. We also want to enforce a password length. So let's type if not validator is length rec body password. Here we pass a length range object with minimum of 8 characters and maximum of 25. Then again, we're going to populate the errors for the password key. Please ensure that your password has a minimum of 8 characters. Now we're done with this function. Because the errors object was passed into this function, it will be modified in place, so we do not need to return the errors object. Now, other than this basic string validation, we need to make sure that there isn't an existing user with the same email as the address provided in this email form field. For that, we need to query the database. So let's define a wrapper function, exports validate user, function errors rec, type return models user find one where email is rec body email, and then we are going to get value u. If u is not equal to null, then we're going to populate the email key of the errors object. Email is already in use. Please log in or reset your password. Now I need to introduce you a new concept on program execution. When we define the body for validate user where we query the database, this is an asynchronous piece of code. So it will execute sometime in the future, and we will get the result also sometime in the future. And this first portion we defined, the validate create user fields function, is a synchronous piece of code, which means each of these statements will execute sequentially. Now, in order to validate the form fields, we need both this function, which is synchronous, and this function, which is asynchronous. And we need to mix the two together. For that, we need to use a concept called promise and make the entire body asynchronous. We're going to cover promises in the future in more detail, but for the time being, what you should know as a recap is that this piece of code is asynchronous and this piece is synchronous. And in order to make use of both in a single function, we need to define a promise which wraps the entire code in an asynchronous body. So for that, let's type return new promise function resolve reject. And we're going to create the promise body. Let's cut this piece, paste it here and indent it inside the promise. And let's make a call to validate create user fields errors rec. And we will return the errors variable in resolve errors. And let's not forget to include the models variable. So let's go to the top and type let models equals require / models. Now let's save this file. Now let's go back to controller / user.js and import validate user. So let's type const validate user equals require validators / signup. Now let's go down to the signup handler and declare a new variable let errors equals an empty object, and we're going to call return validate user errors, and we're going to pass the rec object that contains the input fields to be validated. So let's move on and type then errors, which is going to be the result we get from validate user, and we're going to check whether the errors variable is populated with any values. So let's type if not is empty errors, which means the errors object has some values. We're going to call a new method re-render signup, and we will re-render the form just as we will render the form for the first time using the show signup handler, except we're going to display the error messages that we have populated during the validate user call. So let's add the errors variable here, errors, and we're also going to pass the usual rec, res, and next objects. Now, this case covers the case where we have errors on the form, and we will handle this successful case here as well. So let's type else, and inside the else body, let's cut and paste rest of the code. And let's indent it. So this means if there is an error, we're going to re-render the form, and if not, we're going to save the data to the database. There's one more thing we forgot. This isEmpty function is a call that's been provided by the Lodash library we just installed. So we need to type const isEmpty equals require Lodash. Now is a good time to define our re-render signup function. It's going to be identical to show signup with a few differences. So let's copy and paste show signup, and we're going to make this a local function. So let's type const re-render signup. Now, even though re-render signup looks like a request handler such as show signup, it's actually just a function call. So we're free to modify its function signature with the order of parameters being passed. Normally in Express.js, the request handlers have a particular order in their parameters. In particular, the request, response, and next objects are passed in that order. So re-render signup is called from the signup handler at this point, and we can pass the errors object as its first parameter. And we're then going to pass that to the errors key so that errors can be displayed on the form when the page is re-rendered. We also have another field called form data, and form data is a name that we made up in particular for when there are errors on a form. When we re-render that page, we use form data to pass back all the input fields that have been modified by the user, so that, let's say, when there are errors, the user does not have to re-enter the same information to the other form fields again and again on each time the form is re-rendered. So we save the user time by passing back the data that's been entered already in a previous submission. So in order to pass that data back to form data key, we are going to use rec.body. If you recall, if we go down to the signup handler, when the form is submitted to us, we have all the form input fields available to us in rec.body object with the keys corresponding to the input names, such as email and password. So by passing back rec.body after the submission, we are effectively passing back all the input fields that have been submitted to us on the form submission. So we're passing rec.body back in form of the key form data. Now, if you recall, show signup is using user/signup view, and we're using the same view in re-render signup as well. So we're going to modify the signup view to cater for both cases of the showing the form for the first time and also re-rendering the form with errors and existing form information. So let's go ahead and open up views/user/signup.pug to modify it and to use form data and errors fields. Now let's take a look at the first input field with the name email. We can pass back existing values on an input field using the value property. So here for the value property, we're going to type form data.email. We could potentially populate the value property of the password field as well, but we're not going to do that as password is a sensitive field. So let's add error message information now. And let's create a new line under the first input. And let's type if errors and errors.email, which is the name for the input field. We're going to type p.small.textDanger. These are classes from Bootstrap. And we're going to finally display the error message errors.email. If you recall, we create these messages in the validator function. Let's do the same for the password field. So I'm going to create a new line under the password input field. And let's type if errors and then errors.password p.small.textDanger errors.password. Now let's save our file and we should be ready to try what we've done so far. Now let's go back to our browser window and go to the /signup route, and I'm going to type user@email.com. We know that we have a user already with this email address, so let's see what happens when we include that. And for the password, I'm going to type 4-character password, which should also trigger an error. So if I click on sign up, I do get the form re-rendered with the right error messages. Notice how the validator has both detected that the email is already in use. We've done this with the database query, and the password length was also detected to be not valid. Let's check in all the changes we made. Git add validators. We've added a new directory validators, and we've implemented error handling and form validation for sign-up route. In this tutorial, we're going to learn how to implement access control in our application. Also, we will learn the concept of a middleware and how to use it in Express.js. The problem with our application in its current form is that the leads link here is open to public. Anybody can click on this link, view our links, or edit them. And we're going to fix that. So let's open up our editor and go to routes/index.js. In Express.js, a significant property of route definitions is that we can introduce a sequence or a chain of function calls before we make a call to the final handler for that route. Let me show what I mean with an example. I'm going to introduce a new call right after the path component called noop and place a comma. And let's define noop with const noop equals function rec res next and an empty body. As you recall, the handlers in Express.js have this particular function signature where there is first a rec object and then a res object and the next object. And we've never made use of this next object here. So we're going to make a call to next and leave it at that. What this does is that when the /leads path is matched, the first function to be called is going to be noop. And noop will transfer execution to the next one in line, which is show leads. And the way we do that is by making a call to next. I could potentially add additional noop calls here, and it will be all the same because noop does nothing but transfer the control of execution to the next one in line. In a route definition, we have the capability to add as many calls as we need to any separate handlers before we call the final handler. And this gives us a lot of flexibility for adding additional functionality to each route. And we're going to see one example shortly. Before we move on, I want to demonstrate you that these noop calls indeed have no effect and we are able to call show leads as normal. So let's go to our browser window and click on the leads link. And we're still able to see the leads as usual. Now let's go back to our editor window. If you notice, these noop calls are in the middle when handling the request for this route. That's why they're called middleware. Middleware may sound like a grand term that does something complex, but a middleware can merely be a simple function call such as this node function. And let's remember that in a middleware function, we always need to make a call to next in order to proceed the execution to the next one in line and make sure that the final handler gets called. Now we're going to define a really basic middleware. First, let's delete this node call and delete these calls in the middle. And let's create a new folder called middleware in our root directory. And we're going to create a new file called hasauth.js. Let's type let create error equals require HTTP errors. Create error function allows us to create an error object with an error message, and we've already made use of this in app.js, and it comes as standard with the vanilla Express.js installation. So let's go back. So let's define a new method, exports is logged in equals function rec res next. If rec.user, then we will call next. The presence of rec.user means that passport.js has authenticated the user, there's a session, and there's a logged in user who is requesting the page. So we're allowed to go to the next step of handling that page. And else, we're going to create the error, create error 404, and we're going to give the message page does not exist. Now, there's one thing I need to mention about how this next works. In the successful case, we're calling next to move on to the next handler, but in the error case, we're also calling next. So how come we're showing an error message when we call next, which should normally call the next handler for this route? Well, the answer is in the Express documentation. If you pass anything to next function, Express regards the current request as being an error, and it will skip any remaining non-error handling, routing, and middleware functions. What that means is we're going to skip all the route handlers that are coming next, and we will go straight to our error handler using the object we're passing here. And that error handler is in app.js. If you scroll down below, you will see this error handler already defined for us. When we pass an object, then that means that this error variable will have that object being passed from next, and we're going to display an error message and render the error page. So that describes how next will work in both cases of a success and error. Let's save this file and go to index.js under routes folder, and we're going to import this function we have just defined. So let's type let is logged in equals require ... middleware / hasauth.js, and we're going to use is logged in the leads route as our middleware. So let's type is logged in and then a comma. Let's save this file and try our application again. So I'm logged out, and I'm going to reload this page, and I'm going to click on leads. Let's see what happens. Indeed, our middleware has found that the page does not exist and generated a 404 error. While we're at it, I want to beautify our error page as well. So let's go back to our editor and open up views/error.pug, and I'm going to copy and paste code that I prepared earlier for this. We're using a few bootstrap classes. Let's save and reload this page. Now this looks better. Just to note, we're able to see exactly what happened in the application, and that's because the application is running in debug mode. If we were running in the production mode, we wouldn't see this error stack. Now, just to demonstrate you the other case, let's go back to the landing page and log in. I'm going to type user@email.com and sign in. Now, if I click on leads, I'm able to still see the leads. Now, every user has access to our leads table, so we're going to take our access control concept a little further and only allow a particular user to have access to these pages. So let's go back to our editor and create a new migration under migrations. Let's create a new file with today's date. We're going to add a new field called isAdmin to the users table. I'm going to copy and paste code that I prepared for this earlier, and let's go over it quickly. So what we're doing here is creating an isAdmin field which is a Boolean, and when it's true, we will consider the user as an admin of our application. And here we have the up method for the migration, where we add the column to our table, and the down method, which will remove this column from our table called users. Let's save this file and go back to our terminal and type sequelize db migrate. So we've successfully migrated our table and added an isAdmin Boolean field to our users table. Now let's go back to our editor. I'm going to make a modification in the way we create new users. Let's go to controller/user.js and the signup handler. Now, if there are no users in our application with an admin flag as true, we're going to create the next user as an admin. And for that, I'm going to modify the signup handler. Let's type return models user find one where isAdmin is true. Then user, and if user exists, that means user not equal to null, then we're going to craft the user row as normal. So let's cut and paste the way we create the first user. And else we're going to create the user with the field isAdmin equals true. And for this to work, we need to first declare new user outside, use the new user variable, and finally we're going to save the user back to our database. So let's place this after the else statement. Let's save this file and check that our application is running correctly. What we haven't done is update our model under models with the isAdmin field. So let's create an isAdmin field under here at the bottom. I'm going to copy and paste code that I prepared for this earlier. So isAdmin is a Boolean and we allow it to be null because the existing users won't have this field set. Let's save our model file and go back to our browser and let's sign up as a new user. And I'm going to type a password for that and press sign up. Now we have admin@email.com signed in, and let's go back to our terminal to verify that this user was indeed created with isAdmin as true. Insert into users, first, second, third, and fourth field is isAdmin, and I can confirm that admin@email.com is confirmed as an admin in our application. Now we're ready to implement the isAdmin check in our middleware. So let's go back to our editor and go to middleware/hasauth.js. And I'm going to define a new function here, exports.hasauth equals function recres next. And if rec user is not null and rec user.isAdmin is true, then we're going to call next as usual and allow access, and else we're going to create an error as before, next create error 404 page does not exist. Let's save this and let's go back to routes/index.js to import this new method hasAuth, and we're going to replace the isLoggedIn middleware with this one. So let's type hasAuth and save this and open up our browser and let's reload this page. And I have the leads link here. If I click on this link, I'm still able to see the leads. And I'm going to log out now and log in as another user that I just signed up as, which is noadmin@email.com, and log in. And if I now click on the leads link, I'm redirected to the page does not exist error page. So this effectively demonstrates our use of the hasAuth middleware in order to control access to certain pages on our application. We now want to extend this to other routes where the leads are edited and accessed. So we're going to add the hasAuth middleware to other routes as well. So let's type hasAuth for show lead, hasAuth for the edit lead, and the rest. Now all of our routes are protected by the hasAuth middleware, except the first one, which is for visitors and the landing page. Now let's check in our changes. Let's type git add middleware, git add migrations, git commit -a, and implement hasAuth middleware and is admin flag. Lead routes are protected by hasAuth and only the admin user has access to them. I hope you enjoyed these tutorials. My name is Bahadur. I am a system software engineer. My background is in low-level software and operating systems. If you enjoyed these tutorials and want to be notified of similar content in the future, you can go to this website and join our community here. If you scroll down below, you will see a button to join. It's free. Thank you for watching these tutorials, and I hope to see you in another tutorial in the future.